Retrieval Augmented Generation, commonly known as RAG, and fine-tuning are two of the most widely used techniques for improving the usefulness of large language models. Although they are often mentioned together, they solve very different problems and are designed for different types of workloads. Understanding the difference between these two approaches is critical when building real-world generative AI systems. Large language models are trained on massive datasets, but that training happens only once. As a result, models do not automatically know about new information, private enterprise data, or frequently changing content. They can also sometimes generate answers that sound correct but are factually inaccurate, a phenomenon commonly referred to as hallucination. To address these limitations, architects typically use either retrieval augmented generation, fine-tuning, or a combination of both. Let's start with retrieval augmented generation. RAG enhances a language model by providing it with relevant external information at the time a question is asked. Instead of relying only on what the model learned during training, RAG allows the model to reference additional data sources dynamically. In a typical RAG architecture, documents such as PDFs, web pages, or internal knowledge base articles are first converted into numerical representations called embeddings. These embeddings are stored in a vector database that allows fast similarity search. When a user submits a query, the system retrieves the most relevant documents and passes them to the language model as contextual input. The model then generates a response that is grounded in this retrieved information. Because the data is supplied at runtime, the system can respond using up-to-date domain-specific, or private information without modifying the underlying model. One of the biggest advantages of RAG is that it significantly reduces hallucinations. Since the model is answering based on retrieved facts rather than guessing, the responses are more accurate and trustworthy. RAG is especially well suited for applications such as enterprise search, customer support systems, internal documentation assistance, and compliance-driven environments. Another important benefit of RAG is flexibility. When documents change or new data becomes available, you simply update the vector database. There is no need to retrain or redeploy the language model itself, which keeps operational costs low and system maintenance simple. Now let's talk about fine-tuning. Fine-tuning works in a fundamentally different way. Instead of providing external data at runtime, fine-tuning modifies the behavior of the model by training it further on specialized datasets. During fine-tuning, curated examples are used to teach the model how it should respond in specific situations. These examples might include preferred writing styles, structured output formats, domain-specific language, or task-oriented responses. Once fine-tuned, the model internalizes these patterns and applies them automatically to future prompts. Fine-tuning is particularly useful when consistency is critical. For example, if you need the model to always respond in a specific tone, follow a strict format, or behave like a domain expert, fine-tuning can be very effective. Because the model does not need to retrieve documents at runtime, responses can also be faster. However, fine-tuning has some important limitations. If your data changes frequently, fine-tuning becomes expensive and impractical, because retraining is required every time the information needs to be updated. Additionally, fine-tuning is not ideal for injecting large volumes of factual knowledge, especially when that knowledge must remain current. This brings us to the key comparison between RAG and fine-tuning. RAG is best suited for handling dynamic, frequently changing, or private data. Fine-tuning is best suited for shaping how a model behaves rather than what it knows. In practice, many production systems combine both approaches. Fine-tuning is used to define consistent behavior and response structure, while RAG is used to supply real-time knowledge. This hybrid approach delivers both accuracy and consistency at scale. So how do you decide which approach to use? If your primary challenge is keeping information fresh and reducing hallucinations, RAG is usually the right choice. If your primary goal is consistent tone, structured outputs, or task specialization, fine-tuning may be the better option. And if you need both, combining them often produces the best results. To summarize, Retrieval Augmented Generation retrieves knowledge at runtime, while fine-tuning permanently changes model behavior. Both are powerful tools, but they serve different purposes. Choosing the right approach depends on your data, your use case, and your operational constraints. Hope you enjoyed the video. Thanks for watching.